In this video, we are going to talk about logarithmic differentiation. We know that if we have a function, let's say y equal to x square, where x has the power as number, then when we have to find the derivative of y with respect to x, then on the right hand side, we can apply the power rule of derivative, which says power comes on the side x and you subtract 1 from the power, which gives you 2x. So just know that power rule is applicable whenever the power is a number. For example, if you have y equal to x to power 5 and you have to find y dash, that is derivative of y with respect to x. Since the power on x is 5, which is a number, so we can apply the power rule of derivative, which gives us 5x to power 5 minus 1, which gives us 5 into x to power 4. But now let's say we have to find the derivative of this expression y equal to x to power x, and we have to differentiate y with respect to x. Now please see this. The power on x is not a number, it's a variable. So whenever it happens that power of some variable is another variable or just a function in a variable, then you cannot apply the power rule. The power here is not a number, but it's some function or it's a variable. In that case, you do the logarithmic differentiation, meaning that to find the derivative of variable y with respect to x, what you will have to do first is take ln on both sides, which is a natural log. Now you know a property of natural log. Ln of a to power b could be written as the power b comes on the side and it is equal to b ln a. If you have ln, let's say 6 to power 7, this could be written as 7 ln 6. Back to our question, ln y is equal to this x comes on the side by the log property. So first you take ln on both sides, then use the log property and then differentiate this expression with respect to x, because you have to find dy by dx. Derivative of ln y with respect to x, since ln x derivative with respect to x is 1 over x. So here, back to our question, derivative of ln y is 1 over y, and then derivative of y with respect to x. Now we have to find the differentiation of x into ln x with respect to x. Since x into ln x is the product of two terms x and ln x, so we will apply the product rule of the derivative. First term as it is, and the derivative of second term is ln x and its derivative is 1 over x, plus first term derivative, first term is x, its derivative is 1, and the second term as it is. We can see that x cancels out with this x. We have 1 over y dy by dx is equal to 1 plus ln x. Since we had to find dy by dx, so we will keep dy by dx here and take y up on the another side. Now y in the beginning was x to power x, so here in the place of y we will write x to power x 1 plus ln x. So here we have found the derivative of y, which was x to power x. So this is called the logarithmic differentiation, that here first you take ln on both sides, then you apply the log property and then you differentiate the expression with respect to x, just like here, and then you separate dy by dx on one side and everything else on another side. Let's attempt another question of logarithmic differentiation. We have to find the derivative of this expression y equal to x to power sine x. Again, we can see that the power of x is not a number but a function in the variable x. Whenever it happens, you will have to solve this function using logarithmic differentiation, meaning that you write the function as it is, take ln on both sides. By the property of the log, this sin x, which is the power, it will come on the side and you will have sin x into ln x. Now you will differentiate this expression with respect to x. Left hand side, which is ln y, its derivative is 1 over y dy by dx. And on the right hand side, we have an expression which is the product of two terms. So we will call sin x as the first term and ln x as the second term, and we will apply product rule of the derivative. First term as it is, derivative of second term, since second term is ln x, its derivative is 1 over x, plus first term derivative, since first term is sin x, its derivative is cos x, and second term as it is. Since we need to find dy by dx, so we will keep it here and bring y up by cross multiplication. And we have sin x by x plus cos x into ln x. Since y was equal to x to power sin x, so here we will replace this value x to power sin x and this expression as it is, sin x by x plus cos x ln x. So this is how we apply logarithmic differentiation to find the derivative. Let's attempt another question. We have to find the derivative for an expression y which is equal to x square plus 3 whole power ln x, and you have to find dy by dx. Again, you can see here that the power of x square plus 3 is not a number, but it's something in terms of x. More precisely, it is ln x. So whenever it happens that the whole power is not a number but a variable x or something in terms of x, then you will have to take log or natural log on both sides. So we take ln on both sides first before we calculate the derivative. Taking ln on both sides gives us x square plus 3 whole power ln x, ln y equal to, then the log property says that this ln x will come on the side and you have ln of x square plus 3. Now on the right hand side we have two terms, one is ln x and another is ln of x square plus 3. We will differentiate this expression with respect to x. So derivative of ln y with respect to x is 1 over y and then dy by dx equal to, and for the right hand side derivative we will apply the product rule of derivative, which says first term as it is, derivative of second term ln x square plus 3 is the second term, its derivative is 1 over x square plus 3, and then the derivative of the inside term which is 2x plus 0 plus first term derivative, first term is ln x, its derivative is 1 over x, and second term as it is. We'll keep dy by dx here and bring y up, and then we have ln x into 2x divided by x square plus 3 plus ln of x square plus 3 divided by x. We had y equal to x square plus 3 whole power ln x, which we will replace here, x square plus 3 whole power ln x, and inside we have ln x into 2x divided by x square plus 3 plus ln x square plus 3 divided by x. So we have found dy by dx by using logarithmic differentiation. Let's find the derivative of this expression y equal to x cube into 1 plus x square root x minus 1 divided by x plus 1 whole power 1 by 5. And we have to find the derivative of this expression by logarithmic differentiation. First, we will write this expression in a bit simplified form. Y equal to x cube into 1 plus x square, and the square root could be written as 1 by 2 into x minus 1 over x plus 1 whole power 1 by 5. Now we recall a property of log. Ln of a to power b could be written as, the power b comes on the side, ln a. And there is this another property, ln of a over b could be written as ln a minus ln b. That is, ln of the division term could be written as ln of numerator minus ln of denominator. So we have to find the derivative of this expression. Before we find the derivative, we will take ln on both sides. When we take ln on left side, it gives us ln y. And when we take ln on the right hand side, it gives ln of x cube into 1 plus x square whole power 1 by 2 x minus 1 over x plus 1 whole power 1 by 5. In addition to these two log properties, let's also look at the third log property, which says whenever two terms are being multiplied and you have to take ln on these terms, then you can write this as ln a plus ln b. Means the product could be written as the sum. Let's say you have three terms, a into b into c. Then log property says you can write it as ln a plus ln b plus ln c. Let's get back to our question. So left hand side is still ln y, but on the right hand side we can consider that three terms are being multiplied, x cube, 1 plus x square to whole power 1 by 2, and this expression. So by the log property, ln of the product of three terms could be written as the sum of three terms, which is ln x cube plus ln 1 plus x square whole power 1 by 2 plus ln x minus 1 over x plus 1 whole power 1 by 5. Now another log property, that this power 3 comes on the side and you have 3 ln x, plus the same way the power 1 by 2 comes on the side and you have ln 1 plus x square. Another log property, that this power 1 by 5 comes on the side and you have ln of x minus 1 over x plus 1. We can further simplify this right hand side, 3 ln x as it is, 1 over 2 ln 1 plus x square plus 1 over 5. Here we are applying the log property. Ln of division term could be written as ln of numerator minus ln of denominator. Now that our expression is written in a simplified form, now we will differentiate this expression with respect to x. Doing that, left hand side, derivative of ln y is 1 over y dy by dx. On the right hand side, 3 as it is, ln x derivative with respect to x is 1 over x plus 1 over 2. Ln 1 plus x square derivative is 1 over 1 plus x square, because ln x derivative is 1 over x. Here we have 1 plus x square, so it comes down. And then the derivative of 1 plus x square, which is 0 plus 2x plus 1 over 5. Derivative of ln x minus 1 is 1 over x minus 1, and then the derivative of x minus 1, which is 1 minus 0, minus ln x plus 1 derivative is 1 over x plus 1, and then the derivative of x plus 1 is 1 plus 0. We have calculated the derivative. We are bringing this y up and simplifying this right hand side expression as 3 by x plus 2x by 2 into 1 plus x square plus 1 over 5, 1 over x minus 1 minus 1 over x plus 1. Since y in the beginning was equal to this, so we will write dy by dx is equal to y as in x cube square root x square plus 1 over 5 power on x minus 1 over x plus 1, and inside we have 3 by x. This 2 cancels with this 2 plus x by 1 plus x square plus 1 over 5. Here we can take the LCM, x minus 1 into x plus 1 and x plus 1 minus x plus 1. This x cancels out with this x, and you have dy by dx is equal to this expression 3 by x plus x over 1 plus x square plus 2 over 5 into x square minus 1. So this is how we attempt a question by using the logarithmic differentiation, that before you find the derivative of the given expression, you can simplify that expression by using the log properties. So here we had the expression y equal to x cube square root 1 plus x square into x minus 1 over x plus 1 to whole power 1 by 5. So we had taken first ln on both sides, and you can see that on the right hand side we applied the log properties and we continued to simplify first. After we had applied the log properties, then we found the derivative of the expression with respect to x, and applying the log properties simplified our question, and we were able to quickly find the derivative. This is how we attempt the logarithmic differentiation questions. Let's have a look at one more question. We have y equal to ln x to power 10x, and we have to find dy by dx. So what we shall do is, since we know that here ln x power is 10x, not a number, so we cannot apply the power rule. So what we shall do is we take ln on both sides. It gives us ln x power 10x. Then right hand side, by applying the log property, this 10x comes on the side, and you have 10x into ln of ln x. Now please know that ln itself is nothing. Ln of some number, ln of some variable, ln of some expression, all these things make sense. If we look at the right hand side, we can see that we have two terms. One is 10x and another is ln of some term. Again, ln of some term. Ln itself is just an operator. So on the right hand side we have two terms. Now we will differentiate this expression, differentiate with respect to x. On the left hand side we have derivative of ln y, which is 1 over y dy by dx. On the right hand side we have two terms which are being multiplied, so we will apply product rule of the derivative. So first term as it is, which is 10x, and then the derivative of ln x. So ln of ln x, its derivative is 1 over ln x, and then the derivative of this inside term, which is ln x, its derivative is 1 over x. So this is how you find the derivative of ln x. Back to our question, first term as it is, and then the derivative of ln x, which is 1 over ln x, and then the derivative of ln x, which is 1 over x, plus first term derivative, which is tan x, and its derivative is secant square x, and the second term as it is, ln x. Now we will keep dy by dx on one side and bring this y up and simplify the right hand side expression, which is tan x over x into ln x plus secant square x into ln x. We know that the y expression was equal to ln x power tan x, so we will write dy by dx is equal to ln x to power tan x, and then this expression as it is, tan x over x ln x plus secant square x ln x. So this is how we attempt to find the derivative of an expression by using logarithmic differentiation. That first you take ln on both sides, then use log property to simplify your question, and then find the derivative of that expression with respect to x. So this is called logarithmic differentiation. In the next video you will see that we will try to further find the derivative of the function by applying the log properties.